Welcome everyone to Inside Gyros. This is video number 1 of the test flight. The idea tomorrow is to take this bird for the first time in the air, but before we do that, the machine should go for different stages. The first stage is the quality control. It's 2 filters, the one from the production and the one from Airgyro. And then the pre-flight check. In this case, we will have the full covers open, no rotor. We will check the controls, and join me today for a small explanation about what we do with the engine, all the parts that we are checking before the flight, and make sure that everything will be fine. Then in the airfield, we will do a small jumps on the runway, nice and easy, and when we check again that everything is ready, we will take it in the air, so you will see the machine for the first flight in the air. It's a little bit chilly here in Poland. It's -3 degrees today, so I will try to do as fast as I can before I freeze myself. Thanks for watching, and welcome to Inside Gyros on the pre-flight check for the first time and a test flight. So, all the pre-flights, it should start in the front. Before the takeoff and the normal pre-flight inspection, you start from the front and you check the mast is straight, you shake a little bit the rotor, you make sure the controls are not bent, etc. What we're doing now, before we install the rotor, that we will do it in the airfield, is to check the frontal part of the AG915 of the machine. So here we have the nose landing gear, and it's a moving part plus the pitot tube. The components here that we have, there are 2 barrels making the steering, and the steering is controlled by the pedals. They also connect directly with Teleflex to the tail. So what we're going to inspect right now is inside here, they should be the torque marks, the screws attaching the U, and we're going to check the movement. Because we have the nose windows, we can check the push rods inside of the tunnel, that they're not grabbing any cables. There we have the battery also, and we check the action of the pedals, plus the normal movement of the steering control. Then inflation and everything. Both of the attachments on the bearings are connected with the crown washers, so we just check that all have the same torque marks, safety pins. Everything should be pristine, clean. So this is more or less, we just shake it a little bit, make sure there is no play, and make sure there is no grabbing here in the cabin in the front. So this is the initial part of the pre-flight. We just put the machine on the top. They're really well balanced. They just go back. The CG is right in the right place, so they can stay in the tail or they can just go below. And this is what we have. So we can check the motion. We can check there is no play. There is no play inside, and the bearings are working perfectly fine. So after we check the front part, we come to the cabin. Just make sure that everything is off. Before we take the machine in the air, it's important to recheck and go to the checklist. But in this case, we're just gonna see the final items that we need to check, and just make sure that we're not going to have any issues in the air. Sometimes if you're in the air and some of the chairs have an issue, or the small pockets that protect the controls, or the pedestal, or some of the switches, they're not well connected, or they're a little bit loose, they can generate a risk for the flight. So this is the last thing we want, is some distractions. We need to make sure that all the things not relevant to the flight, there should be completely attached and safe. So any distraction can lead to a chain of reactions, and then you will have an issue. So this is what we want to avoid. So we start with the seat belts. Make sure that the seat belts are okay. This is one of the basic configuration of the ones we have. In the Centurion, we have the automatic ones for the cars that are more safe and they're more comfortable to fly. These ones are okay. They're a little bit uncomfortable. That's because we're putting some, protection here for the neck. That sometimes it gets really annoying. These 4 points for the neck. We check the chairs that they're okay. They're fully assembled. They are not going anywhere. And also we check the. If we remove here real quick. You can see here, if you allow me to remove this 1 second, you can remove the chairs and make sure the holding points, there is 2 locking points in the front. You're just keeping the chair down and in 3 positions. Of course, for me, it will be really front. I have no legs, but for the normal person, it will be way back. But this is one of the good things about these models that you can check. You can remove the chair. And then you can check all the components. You can check that the fuel tanks are well attached. There is no leaks on the tube connecting for the refueling area. The locking points of the chair are okay. The teleflex that move the pedals, that move the rotors, go from the tunnel through the tail booms inside here. I will show you later. The controls, we can also remove it real quick. Let's remove this and make sure there is no rubbing. What we're hearing right now is the trims. The Spartan configuration come with the manual trims that they're really good. I like it. This is the roll trim and this is the pitch trim. We only use 2 axes to the pitch up and roll, but in this machine I believe we will not need any pitch up. This is a very light machine with a CG well positioned, so normally even if you lose the control, it tends the nose to rise a little bit. So that's very good. The rotor brake that we use is a very simple solution that when the control goes full forward in a negative position, not in a flight position, a negative position up there, I will show you later, it hits a brake pad. So it will keep the rotor stop when they're in the ground. There are some minor things of makeup that we will address later. We may have some rattling in the air of the doors. Then we'll put the gaskets and the protections. We just check the safety wire on the pedals, that inside the tunnel when all the attachments for the control system that are well done. There is no cracks. They use rivets and they use screws. We also, let me put this back real quick. We're also gonna check the switches, the battery backup switch, the power switch, the circuit breakers, the magnetos, the starter, the lights are in. There is no loose on the panel. The pedestal is also well done. Here we have some inspection windows. Sorry, I'm just trying to aim to see you can see my face. There is some inspection windows that we can check the fuel lines, the return line, and the ventilation line. So this is more or less, there are just few points that we check that just make sure that we will have any distraction in the air. So the non-relevant things like the chairs and some things that, will not kill you, but if you have an issue in the air, they will distract you. In a test flight, it's very important to be focused on the rotor, controls, and engine. So then you can start building your time. It takes more than one flight to understand the machine and to test it. That's because one of the reasons that the FAA wisely asked for 40 hours. Maybe can less if the machine will be fully built. But when you build it by yourself, it's better to fly as much as you can understand your machine. You can learn about the machine. So the 40 hours flying around the circuit or flying around your neighborhood really, really helps you a lot to understand the machine, to go for a full cross country or just start taking passengers. Right, so when we finish the the cabin and checking that everything is off, that there is no wires, there is no things around hanging, that the chairs are fully mounted, that we're not gonna start, rocking a rocking chair around in the takeoff or something like that. We go to the engine. Right now, I remove all the covers so you can see the 915 Rotax 915 configuration, the settings we have here. I want to mention in this part of the video that this is not an instructional video. You should not use this video and following as a standard checklist. Rotax and the AG915 comes with a specialized and section by section checklist that you should make. What is important to do is not just make it once, try to make it at least twice. After the assemble, before the test flight, and do the standard pre-flight before, in the moment right before the takeoff. So let's continue. This is the normal configuration. It's been around for many years. Right now what we have in the 915 engine is we have two water radiators that comes from the NACAs. That is going really good. There is a lot of air coming to these radiators. Plus we have a dynamic intake that we are using right now. It goes from, in the cover, there is another NACA air scoop entrance here, and it goes directly to the turbo. We have one of the fuel filters, fuel selection pressure system. The fuel pumps are here. The intercooler for the air turbo is right here. So what we check normally in this is all the clamps and all the sections that are getting together with these with the hose and these rubber hose. They're well assembled, and they put a torque mark at the end. We check spark plugs. We check the line from the rotation that is clear, that is not touching any hot surface. The oil should be, this engine is being run a couple times here in the ground testing. The wastegate is protected for the temperature because it's right there from one of the manifold on the exhaust. The water lines, they go around in the radiator number one. All the safety pins, safety wires, torque marks, and everything is said it should be clean, it should be pristine at this time, at this moment. Oil pumps, the oil cup should be, check the oil. Is very handy also when you have, in these models, they have a big windows, so you can really see all the gyroplane. And one of the things that I really like is the controls are visible. Like in the tandems. So when you open the cover here, you can see the controls and you can check the play of the controls. They are not stuck. You can see the mixer inside. Here we have the newer scoop that I will explain later in the other videos. That comes from the other NACA direct cold air blowing on top of the engine. That's really good. These engines are really hot, and the fact they're in the back, they have a lot of temperature issues. So what we're trying to do is just to make as much air coming and all the NACAs right now on the test runs what we have, and when we take it to the airfield, we will run the machine for a while in the ground, and temperature should not go to the red line. Engine mounting, just check the engine mounting, all the torque marks. You can shake it a little bit and make sure it's not going anywhere. I think we always say that when we shake something or we want to attach something. Taking this position, we can also go ahead and check the brakes, the landing gear attachment. There is two attachments here below that I will show later. There's two attachments on the tail boom, the brake lines, the inflation of the tires. Everything should be clean and pristine. So if you have the chance, you can check with the torque range. Just make sure that everything, check and recheck is not bad. It's actually good, because normally when you do it for the first time, everything should be fine. But when you do it twice, you may find something else. And I'm pretty sure after the test flight, we will get some other bugs to fix. Sometimes the indicator is not right. Sometimes some electrical issues that we have to fix. There's many things that come up. That's because we do testing. We don't just jump immediately to the operation. So this is more or less what we do in this side. Then we go inside of the tunnel from the tail, checking in this. We use this flow because You finish here on the cockpit, on the pilot chair, then you continue this side, check the tail, check the inside from the tunnel, and then you find your pre-flight on the ground on the other side, on the right side of the machine. And then we go up and we check the controls, and I will explain a little bit more there. All right, we're in the tail. The tail, it has some components. The rotors, dual rotors, very nice stability. The horizontal stabilizer, that is normally glue. After you finish your assemble, you glue it inside with silicone, and then you have 2 screws in each side. It's right there, as you see, it's right there in the thrust line. So they give you a lot of stability when you're flying. They really hold that tail when you're flying at high speeds. These motors are really stable because of that. The thrust line completely goes, it should go. So what we do here, sorry I give you the back 1 second, I want to move a little bit the rotors, just putting the nose up. So you check your rotors, you check your teleflex here, both of the teleflex here, the small wheels we have in case, you know, we roll, but the idea is not to do that. And then after we check here that the screws are fine, that is not going anywhere, that the parts have the safety wires, all the torque marks, the actuators are well locked, etc. We just go inside of this tunnel area to check the engine from the bottom. With the tail, as I said, we go into the tunnel, and now we will have access, because the design is made to have all the critical parts visible for the pre-flight. Every time you fly in this kind of machine, so you're a sport pilot or a recreational pilot, if you're not having fun, if you're going the air scary, or just, you know, with this vacuum feeling when you leave something in your house and you don't know what it is, and then, oh, Jesus Christ, my cell phone or something like that, well, this removes the fun. So if you're really not having fun flying these machines, that doesn't make any sense. The fact that everything is open here, they give us access to inspect in the pre-flight, and every single pre-flight we can inspect all the components, from the fuel lines that we can check, the intercooler, the fuel pumps, the computer, all the manifold system, oil pumps, oil filter, wastegate, oil radiator. We have a very big, pretty big oil radiator for this kind of engine. And the most important part is the control system. So inside we have the push-pull controls, the push rod, sorry. So they go like this, and we can check. So we can check the controls, and literally we can move and make sure those controls are not going anywhere and they don't have any failure. Also, in the end here is holding the big line, the big strut that is holding the controls from the pedals in the front to the back. And mixing is right here, so we check the safety pin. And this is a general inspection. Here in the propeller we have the belts that should be a little bit loose, so it gets tension when we operate the pre-rotation. So every time the pre-rotation, when we do the pre-rotation, start putting pressure here, the belts get pressure and then transmit in the flexible shaft, clunk, engaging the bendix, and start giving us the pre-rotation, the first 200 RPMs we require for takeoff. There is some cables, there is some wirings. We just check that everything is clean, that all the protections, the isolation for the temperature are fine, etc., etc. So it takes a little bit of time. This is just a review of more or less what we do around here in the pre-flight, or in the check before the pre-flight, and then It's getting very cold outside. Never mind. It's very important for me to show you what we have here on the pre-flight. Of course, we did a private one. We're taking all the time and with the mechanics trying to fix and screw and everything. But this is the right part of the engine. This line that you see here is connected to another of the NACAs that comes from the cover. That one blows fresh air directly to the top of the engine. In this side, what we're checking is electrical system that is here, all the circuit breakers, the computer, the regulators. The second part of the control system, we can check it here. When you open the other window, the inspection window, you can check that in the first flight. This is the second water radiator that is here, is connected, making all the loop. The ECU of these engines and the big oil radiator. Until now, we don't have issues with the temperature, even when we flew in summer. We believe, in case you are flying in a really hot weather, we can also attach another system that is the small fan, the small electrical fan in one of the radiators to chill down the temperature, but it will be fine. I think it's not a big deal. So again, it's the same drill that in the other side. Just check there is the whole harness here. Just make sure there is no losing ends. The starter is here. So all these small parts, engine mounting, should be marked. You should mark every time you finish your torquing. You should mark those parts, and you check that in every single pre-flight. 90% of the components, they're visual, they're visible, even with the covers on. That's one of the reasons I really like this platform, the design of this platform, because when you remove the covers, or when you remove the inspection window, you really have access to almost all the engine. It's very weird that you have to remove it completely. And additionally, the lower part that is always open, so that makes a lot of access to check the parts and be sure in the air so you can have a comfortable flight. So again, just check the landing gear, checking the brakes, checking the inflation. It's more or less repeating what you do in the other side. And again, do and review is a really good option before you take it in the air. Finished downstairs with all the engine and all the components inside of the cabin. We come back to the top. This is really important. You should put a lot of attention here, because you're hanging on this. This is the rotor head. The rotor head have two components. They give you the roll and the pitch. This is the pitch. This is the roll. So the control bars, as you see, they're moving when you move left and right. This is what we're doing. So they're moving the whole umbrella. Remember? So you're moving like this, and this is the pitch. So if you want to go down, you go like this. If you want to go up, you go like this. So this is what we're checking right now, that the controls, there is two movements in two axes. We have the pitch and the roll, right? So in the two cubes, there's two cubes moving like this. So this is what we're moving. So here what we check is the controls are well attached. The mixer and inside, they have a really strong bolts. This here inside, I will try to make a close-up later, is the rotor sensor. Sometimes it's a little bit higher, a little bit lower. Sometimes when it's too low, you will have a weird RPMs or take too much. So we will test that in the air. And here is the rotor brake. We don't have pneumatic system. The pneumatic system just put pressure up here on the here on the rotor disc. So what we do is when we finish the flight, we just go full forward, put the strap, and this will get in contact with here. There we go. It will get in contact. So it will brake. It will make it stiff. So it will brake. So you will not have any issue. There is no pneumatic system, electrical system that can be, annoying you if it loses pressure after time, etc. Also, we have the Bendix here in the back. The flexible shaft, they have some attachment point that we should check. we shake it really good and make sure that it's not going anywhere. The mass fairings, the attachments, there's two units that they're very strong. They're attaching all of these again, and the teeter stoppers, so it will not hit the bendix, or it will not hit something, so it will stop. They leave the tethering of the rotor and the U. Sometimes you have the some shims just to make sure that it's, you know, left and right. We will see in the test flight if we have to, you know, modify. There is very good instruments, Dynavibe instruments. I really recommend to use those ones. There is many forums talking about that. They put the 2 axes and they will let you know where is the movement, so you can rebalance the rotor a little bit, and you can also realign the rotor, or just position the rotor. Sometimes you just move it 180 degrees, or just, you know, it's minimal details. So this is more or less what we check. Of course, there is more time. This is just a preview that I can have in the video. Thank you for watching. Thanks for your comments. I hope you're enjoying. Now you can you will see the next video, that is the first flight of the machine. If you have any other comments, if you want any suggestions about what you do in your pre-flight and your test flight, I would love those recommendations. Again, I'm a rookie. I'm not a former Navy pilot or something like many of you watching. I learned more or less by time in these machines, and what I do is just compare with the last machine that is flying really good and try to make it as similar as possible. But it's about feeling, it's about understanding, and patience. A lot of patience when you take your baby, when you take your bird in the air. Before you take it, just every single detail, just sweat the small details, sweat the small things, because normally the devil is in the small details. So every single thing, take time. Clean the machine. Cleaning the machine, they give you a lot of access to things that you don't see. So when you finish your AG915 kit, when you build it, so you will understand more the machine. There will be more videos. There will be more helping of the builder's assistance for the United States kits. So stay tuned for 2020. Next year we will have a lot of new videos. We will teach the people how to build the machine. Come to Poland if you want to. Our builder's assistants now include Poland for the same price, and you can come here, make the training, fly with us, and have a really nice experience. I'm losing feeling on my hands. I need to come back and drink something warm and get my hat on. But thank you for watching. I hope you enjoyed. Make your comments. Follow us. Have a nice day. And I will get this bird ready for test flight tomorrow. Bye.